and then we'll get started. So guys, see my screen. And you guys see my sorry. Can you guys see that screen? Can you please just let me know if you can see the screen?
Yes.
Okay, cool. Yeah, we'll get started now. So today, we're carrying out calculations with numbers up to 1 million, including strategies to check answers, including estimation and approximation. Have I started this recording? Yes, I have. Cool. So by the end of this session, learners must be able to understand place value. Learners should be able to compare numbers and use inequality signs. Learners could also aim to use approximation in calculations to provide sensible estimates. And learners will be assessed on their ability to understand place value in large numbers and make appropriate approximations to make suitable estimations. So, how we read and write numbers. What is the difference between a number and a digit? There are only 10 digits in our number system. These are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Numbers are made up by combining these digits. For example, 697. The place value of each digit in a number depends on its position or place within this number. The number 1 million is shown below in the table below. For example, you can see, let me just get my annotation up. Sorry, no, that happened. How do I annotate this? Yeah, there you go. So as you can see, there's 1 million, 1 millions, and the rest are 0 because there's the value of them are 0. So that equals 1 million. 1 million has 6 zeros. The digit 1 is in the millions column. So the value of this digit is 1 million. For example, if this had a 1 instead, the value would be 1,100,000. What is the value of the 3? What is the value of the 3 in each of these numbers? So here we can see if we do the table again, go away of me to 1 second. 1 second, guys, sorry. Oh, sorry, guys, I'm just gonna reshare my screen. Give me 2 seconds. So what do you want to see? Cool. So if you see here, sorry. Yeah. So if you see here, if we draw the table is million, 100,000, 10,000, thousands, 100,000, hundred, tens, and units. So it would be millions here. 100 of that, 100,000. 100,000, 10,000, thousands, hundred, tens, and units. So if you look here, how many? There's one, two, and then 1, 2, 3, 4, 5 zeros and one. So it would be 2,000,000, 100,000, 10 thousand, 1,000, 100, 10, and 3 units. So the answer here would just be 3 for the value. For the second one, if we look, is 25,639. So it'd be 0,000,000, 100,000, 20,000, 5,000, 600, 30, 30, and 9. So the answer here would be 30. For the third one, it would be 800, 0,000,000, 800,000, 80,000, 800, 3, I mean, 8, it would be 800,000, 80,000, 8,000, 320, and 4. So it would be 300 there. So the fourth one, it would be 1,300,000, 40,000, 5,000, 200, 0, 10, and 1 unit. So it would be 300,000 here. And the last one, it would be 0,000,000, 100,000, 30,000, 5,800, 0, 10, and 2 units. So it would be 10, 30,000, 3, 10,000. So as we can see, the position of 3. So yeah, that's the answer there. Let me just scribble this one out, guys. So So numbers can be referred to as 1-digit numbers, 2-digit numbers, 3-digit numbers, and so on. For example, 6 is a 1-digit number, just units. 30 is a 2-digit number, tens and units. Sorry, what have I gone? What have I done? Apologies, guys. 837 is a 2-digit number, tens and units. 837 is a 3-digit number, 100 tens and units, and 2,879 is a 4-digit number, thousands, hundred, tens, and units, and so on. Using the digits 2, 3, 7, and 9 to form a 4-digit number, what is the largest number you can make if you use each digit only once? So the largest number is 9 there, so we put 9 first, 7 would come second, third would be 3, and fourth would be 2. So the answer would be 9,732. Now, I don't know why this answer. Sorry, sorry guys, I don't know what's happening today with this. Um, yeah, so numbers can be compared to see which is greater, more, and which is less. Symbols can be used as shorthand. For example, 100,000 is greater than 999,999. 999,999 is less than 1 million. Insert the correct symbol to make the statement correct. So we know that 185,789 is greater than 99,879. We know that 10,000 is less than 99,000. And we know that 87,654 is greater than 9,876. Estimating calculations. Before carrying out calculations, it can be a good idea to have a rough idea of what answer you might expect. We can do this by estimating calculations. Imagine you want to buy several items in a shop and you have £10 to spend. Quickly estimating the total cost can help you decide whether you have enough money to pay for them. Here are the items you want to buy. Magazine, £1.95, loaf of bread, 99 pence, chocolate, 85 pence, bananas, £2 10 pence, and washing powder, £5 19 pence. We can quickly estimate the amount by rounding the values. In this case, we are going to round all the values to the nearest pound. So the first one will be £2, the second one will be £1, the third one will be £1, fourth one will be £2, and the last one will be £5. So if we add them all together, 2 add 1 add 1 add 2 add 5, we get £11. So it is unlikely we have enough to buy all the item as we only have £10 to spend. Even if we do really need to know the exact answer, estimating an answer first can give you the confidence your calculation is correct. For example, calculate. Sorry, I don't know what that is trying to say. I don't know why that's like that. Sorry, guys. But we will change the calculation. So calculate so for example, calculate, let me just think of 100 and 100, no, not 100, calculate 86 by 21, 86, 86, oh no, calculate 86 divided by 4. For example, by rounding each number, we can do a rough calculation to get an estimate. So if we round each number, we can get 100. So yeah, we can round it up to 100 divided by 5. 5, that should be not an 8. 5 equals 20. The approximately equal to sign is this. Is used to show that values have been rounded. The accurate answer is 21.84 to 2 decimal places, which is very close to our estimated answer. So I'm going to read out the next calculation just because the answer's there and I don't want to give the answer straight away. So you want to calculate 203 times 42. The calculator's answer gives you 966. Do you think this could be the correct answer? Can you explain why? So 203, no, sorry, what did I say? 203 multiplied by 42. Round it up, so 200 multiplied by 40, which equals, sorry, what is this? Which equals 8,000. Now, we know that our estimate is nowhere near the calculated answer, which was 966. Therefore, we know that there has been an error in the calculation, and the correct answer, if we check it on our calculator, seems to be 8,526, which seems much more like it. So if we go back, oh my God, sorry guys. Yep, so if you go back, we round it up to 200 times 40. 200 times 40 is 8,000. We would expect our estimate 8,000 to be close to the answer on the calculator, but it is not. This must mean that 966 is not the correct answer, and an error has been made when typing in the calculation on the calculator. The actual answer is 8,526. Similarly, I'm going to read out the next ones because the answer is visible and I don't want the answer to be known. So for this next one, we're going to do an estimation calculation again. Oliver is training to do a 6 kilometers open water swim. He swims around a lake, each lap of which is 987.5 meters. He swims at a steady speed. It takes Oliver 19 minutes and 34 seconds to swim one lap. Approximately how long does it take Oliver to swim 6 kilometers? So we want to work out the approximate. So if it takes him approximately 20 minutes to swim one lap, which is 1 kilometer approximately. So 987.5 m can be rounded up to 1,000 m, which also equals 1 km. Cool. 1 km. It takes him 19 minutes 34 seconds, so this can be rounded up. 19.34 seconds can be rounded up to 20 minutes. So now if it takes him one lap, 20 minutes to do one lap, how long did it take him to do 6 laps? So we would always do and multiply by 6. So we get 120 minutes approximately, or 2 hours. 2 hours and if we look, the answer is, if we go on the next slide, if we look, it's the exact way I've done it. It equals 1,000 meter, which means one lap. 1,000 meter equals 1 kilometers. 19 minutes 34 seconds equals 20 minutes. Multiply it by 6, which gives us 120 minutes or 2 hours to swim 6 kilometers. Let me just move this out, guys. So by the end of this session, learners must be able to understand place value. Learners should be able to compare numbers and using the equality sign. Sorry, this learners could also aim to use approximations and calculations to provide sensible estimates. Learners will be assessed on their ability to understand place value in large numbers and make appropriate approximations to make suitable estimations. So that's what we have learned today. Don't forget to complete your knowledge check. And you have completed this module on carry out calculations with numbers up to 1 million, including strategies. So check answers, including estimation and approximation. Now practice your skills with activities and test your progress with our knowledge check. So that is it for today. It was quite a short session. If you guys have any questions now, by all means, you can ask me. Otherwise, you've also got the chat to ask me. I will send this recording on the group chat. And yeah, that is it for today, guys. Thanks a lot. Thank you, guys. Thank you. Thanks. Bye.